Hi guys! In this video we're going to be talking about the mod operator or the modulus. Now if you've never programmed before or if you've never been in a discrete math class, then the mod operator might be new to you. It's represented by the percent symbol and it calculates the remainder when one integer is divided by another. I have some examples on the screen and I'll go through a few of them with you. Here's the first one. This is 19 mod 6. This produces the remainder when 19 is divided by 6. Now 19 and 6 are both integers. The mod only works on integer values. 6 goes into 19 3 times with 1 left over. So the remainder when 19 is divided by 6 using integer division is 1. Here's another one. This is 14 mod 3. 3 goes into 14 4 times with 2 left over. So the result, the remainder of 14 mod 3 is 2. Now it's possible to get 0 as our answer if a value evenly divides into another, which we can see down here. 16 is evenly divisible by 4, so there is no remainder after that division takes place, and the remainder is 0. So 16 mod 4 is 0. Another interesting case is what happens if we mod by a value that is larger than the original. So this one is 19 mod 200. Now 200 goes into 19 0 times with a remainder of 19. So we're going to go over to the IDE and experiment with this a little bit. I've already prepped this program for you guys. It's just a short little mod example that demonstrates the use of the mod operator. So we've already included our header comment, our preprocessor directives, and an outline for the main function. So inside main is where we're going to add all the rest of our pieces. We're going to create 3 integers that we can use to experiment with, and we're going to assign them some initial values. So we've got A, B, and C. We're going to assign some initial values to A and B, and then C is going to get assigned the value of A mod B. And then we're going to print out the results so that we can kind of see the results of our experimentation. So we'll use our print format function, and we're going to provide the context that goes along with it. So this is the remainder of one value divided by another. And what we want to see is the remainder of A divided by B is this value C. So now if we print that out, we should be able to see the result of, in this case, 19 mod 7. So we're going to go up here to build and run. We'll build and run our program. We're going to see our answer here. The remainder of 19 divided by 7 using integer division is 5, which we can easily double check. 7 goes into 19 2 times with a remainder of 5. And so now we can use this to kind of experiment with any other values we'd like to see. So we could plug each of those examples from the slide in so that we could double check their responses. Here's the one of 19 mod 200. The remainder of 19 when it's divided by 200 is still 19. So feel free to play around with that and see what else you can see when you're experimenting with the mod operator. Now we can mix mod with some of our other arithmetic operators like multiplication and division. It has the same precedence as those two, as multiplication and division, which means it has a higher precedence as addition and subtraction. So here's a quick arithmetic example. Suppose we had this expression. This is 15 minus 12 mod 5 plus 2 times 4. We would first go through the expression and evaluate the higher precedence operators. So we're going to do both the modulus and the multiplication before we do anything else. So first we'll do 12 mod 5. Now 5 goes into 12 2 times with a leftover of 2, so that becomes this value. And of course 2 times 4 is 8, so that becomes this value. And then the resultant expression, the operators with the same level of precedence, in this case addition and subtraction, are evaluated from left to right. Now math's really cool for a lot of things. This is just an example expression, but it's really great for problem solving. So as an example, we're going to do a quick practice program. Suppose that we're given the height of the user in inches. We're going to use the mod operator to print out how tall they are in both feet and inches. So we'll go ahead and do that together. We're going to first start a new file. So we can go to File, New, Empty File, and that'll give us a new blank space that we can work in. First thing we should do is make our header comment. This program prints out how tall the user is. So notice right now that our text is black text on a white screen. That's because we haven't saved it yet. Remember, when we save it, that's when we get the syntax highlighting. So I'm going to save it in the folder that I made for our class. We're going to call this height.c. Remember to save everything as a .c file. And as soon as it's saved as a C source file, that's when we get our highlighting. We're going to include the standard input and output library every time so that we have access to our input and output functions like print format and scan format. Then we're going to create our main function to hold all of our code, which always ends with a return 0. So everything else is going to go here in this space between the start of main and the return statement. Okay. So now we need some pieces of information. We'll create variables for that. The user is going to give us how tall they are in inches. So this will be the total number of inches for their height. And we're going to calculate the inches in feet for how tall they are. These are the three pieces of information we're going to end up dealing with throughout our program. The first thing we need to do is prompt the user for how tall they are. So we're going to prompt them for that information and provide them plenty of context so they know what we're asking. We're going to ask, how tall are you in inches? And they should give us how many inches tall they are. Now we're going to use the scan format function to read that value in and store it in total inches. So since total inches is an integer, let's make sure that we use the correct percent code. So integers get %d. We want to read in an integer, and we want to store it in the variable total inches. Okay, so now we're ready to do some math. We need to calculate inches and feet. So we're given total inches. If we have the total number of inches that somebody is, we can figure out how many feet tall they are by dividing by 12. And we'll get the leftover inches by using the operator that gives us the remainder, the mod operator. So we'll calculate feet with dividing by 12 and the leftover inches by modding by 12. And then we're going to print that final response back to the user. We'll tell them that they are X number of feet and Y number of inches tall based on the information that they gave us. So here's our program. Most programs follow the same kind of basic outline. Got our variable declaration, our prompt and reading in of information from the user, our calculations, and our output. So these are the major sections of our code, and we should comment them so that we can let anybody else reading the program know what's going on. So there's our major sections, our variable declaration, our getting the information from the user, our calculations, and our outputting our results. So now this is a complete program, and we can check it out to see what it looks like. So we're going to go to build and run, which will do three things for us. It's going to save the program, it's going to build it or compile it, and it's going to run it in this run environment for us. So now remember with the scan format function, it's going to sit here and wait until our user provides some information. So it's going to sit here and ask, how tall are you in inches, and just wait until it gets a response. So I'm 63 inches tall, and if I tell it I'm 63 inches, then it will come back and say that I'm 5 feet 3 inches tall, which is accurate. So that is a nice little example program that demonstrates the mod operator. Think about some other problems that you can solve with the mod operator. And in our next video, we'll talk about some common errors. See you guys then!